All right, guys, here is another distance formula example. This one, you can see we've got some negative coordinates here, so we want to be able to work with those. This is one of the guided practice problems from example 2 in your textbook. Okay, so we've got point E at -5, 6, and then we have point F at 8, -4. Okay, so we would want to know the distance between these 2 points. If you wanted to, you could plot these points on the coordinate plane and make a right triangle, and you could find the lengths. You could find the distance between the x points, find the distance between the y points. We could use the Pythagorean theorem, or we can just use our handy dandy trusty distance formula, which is going to help us calculate that distance. Oh, we're gonna need this calculator too. Okay, so we want to just plug the points in, and again, this could be x2, y2 here if you wanted it to. This could be x1, y1 here. It doesn't matter the order in which they go. The answer will come out the same. If you don't believe me, try it, and if you do the math correctly, you'll get the same answer. Okay, so let's go ahead and plug in some points. Okay, so d equals the square root. I have really big square roots. X2 is 8 minus x1, right? This is minus a minus here. Okay, be very careful. Minus a minus, and then so that's going to turn into a plus squared. Okay, plus y2, which is -4, minus 6, quantity squared. Okay, so now we're going to start to evaluate this thing. Okay, let's go ahead and knock it down. Okay, so we've got 8 minus -5. That's the same as 8 plus 5. So that's going to be 13 squared. 8 minus minus is 8 plus, 13 squared, plus -4 minus 6. Right, this is -4 plus -6. Right, this is going to give us -10 squared. And something else I want you to notice here. Okay, so the cool thing about this formula, the reason that it works is, like, we got a negative here, but anytime you square a number, your answer is going to be positive. So we're not going to end up with any kind of a negative under this square root, which is kind of a no-no in square roots. Okay, so negative squared is going to give us a positive. Okay, so use a calculator here, or use your multiplication table showing you the roots. All right, 13 squared. We can punch it into our calculator. So I'll put my calculator here so you can see, although I doubt you have a calculator that looks like mine. 13, and then I can just hit x squared here. 13 squared, it's going to be 169. Plus -10 squared, so -10 times -10 gives us a positive 100. Okay, so then we can combine these, right? So then we've got, and we'll just put it down here. T equals the square root of 269. You could attempt to factor this. This could get a little dicey. You could try putting 3 into this, 3 into 26. Not going to work. Yeah, so I'm not too concerned about this one. You could try and see if you can reduce it. I don't believe it is reducible, though. 269 might even be a prime number. So, but we definitely want to punch that into our calculator. Use Google Calculator or whatever you have to do that. So we'll go, let's go and clear that out. So we've got, for me, I hit second. So that's square root of 269 equals 16.40121947. Blah, 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 blah. So we're going to round that. We'll just round that to approximately 16.4. So the distance between point E and point F on the coordinate plane is 16.4. Okay, and you could draw that line in your triangle if you chose to plot that, and then you'd be able to see that. Okay, so using the distance formula, just plug and chug just like we always do when we have our formulas. All right.